Hey everybody, it's me, Amy, back again with another Dueling Rabbits Productions video about all things Drawloom. Today we are going to dig into one of my favorite subjects, loom mechanics, to consider the creation of what is probably the most common Drawloom structure, damask. Recently, several folks of a technical frame of mind have asked me for a bit more detail about how damask is woven on the loom. How do the Drawloom's two harnesses work together to create the cloth and form the design? It's a good question, and I've enjoyed thinking about the answer. To begin with, I think it's important to examine damask pretty closely in order to grasp its structure. Then we can go to the loom and see how the Drawloom shed works in unique ways to create complex patterns. So, what is damask anyway? Well, it's usually defined as a textile where warp emphasis blocks and weft emphasis blocks are interchanged to form patterns. In single harness looms, these exchanges usually show as stripes or checkerboards, as in the piece you see here. In multi-harness looms, exceedingly complex figurative designs can be achieved. Damask can be woven using a variety of ground structures. It can even be woven using a mixture of structures, but that's a topic for another day and another video. For now, let's look at one common ground structure, 4-shaft broken twill, to explore how damask is woven. Here's my Fiberworks drawdown for 4-shaft twill as woven on a conventional single harness loom. Straight threading, tromped as writ, and tied up as broken twill. As we'll see in a moment, this is the same cloth that is woven on the ground shafts of a Drawloom configured for this structure. In this example, the warp is yellow and the weft is green. This is the side that faces up when it is being woven. It's the weft emphasis side. Note the long, horizontal weft floats, which make this face of the cloth predominantly green. We get this effect because for every row, only one yellow warp thread in every 4 is raised. We can see that in the tie-up here, where the black squares represent connections to rising shafts. If we look at the back of the cloth, that is, the underside when we are weaving, we see the warp emphasis side. This face is characterized by long, vertical, yellow warp floats. 3 weft threads pass underneath each float. This side of the cloth shows as the warp color. Ground structures for damask include 3- and 4-shaft twills and the satins we are looking at now. The drawdowns show that they are all characterized by these perpendicular floats, albeit floats of different lengths and interlacements. Now these structures make lovely textiles. They have great drape and a beautiful sheen where the light catches the long floats, especially if the warp and weft are the same color. But for a lover of complicated designs, they might seem a little, dare I say it, dull. How can we add pizzazz? How can we turn these ground structures into damask? Well, we do that by exchanging, the technical term is counterchanging, the warp emphasis and weft emphasis surfaces so that both show on the same face of the cloth. Let's revisit our original twill draft, the one where the weft emphasis side is up and the warp emphasis side is down when the cloth is being woven. If I choose, I can weave the cloth the other way round, with the warp emphasis side up. The easiest way to do this is by changing the tie-up so the warp floats run vertically to create yellow cloth. You can see here that 3 out of 4 warp threads are raised in every row, whereas in our original draft, only 1 in 4 was raised. How do we change the tie-up? We use the mirrored opposite. In our original tie-up, black squares represented connections to lifted shafts. I've redrawn them in red on this transparency. If I flip it over and lay it on the new tie-up, those red squares are superimposed on white boxes. These are the connections to unraised shafts on our warp-dominant drawdown. Now this would be an unusual setup since the floor of the shed would have very few threads in it, causing potential mayhem with skipped threads and diving shuttles. So why is it important that we be able to do this? Because it enables us to add pattern blocks to our design. Let's start simply with just 2 pattern blocks. On our twill ground, we'll need 4 shafts and 4 treadles for each. We can see what's happening pretty clearly. The green blocks are identical to the weft emphasis side that was facing up. the yellow blocks are identical to the warp emphasis face opposite. If we look at the tie-up, we can see how our blocks are being woven. For the green blocks, we use the tie-up for our weft emphasis twill. For the yellow blocks, we use the tie-up for our warp emphasis twill. Both faces show on the same side of the cloth, giving us our two blocks. Using this principle, we can keep adding blocks 4 shafts at a time. Here's a draft for a 3-block twill on 12 shafts. Let's look at this yellow warp emphasis block here, which is threaded on the 4 shafts at the back of the loom. If we examine the associated tie-up, we can see that it is the same as our warp emphasis tie-up here. If we go to this block, threaded on the 4 shafts at the front of the loom, there it is again. And finally, if we look at the 3rd block on the central 4 shafts, we can see our warp emphasis tie-up again. The green blocks, of course, are woven using our weft emphasis tie-up. For every block I add to my design, I need to add 4 more shafts and 4 more treadles to my loom. On a computer-controlled or dobby loom with 32 shafts, you can thread 8 blocks of 4-end twill, which is a lot, but for complex figurative damask, it is still rather limiting. For this tiny piece with its 44 wee little blocks, I would need 176 shafts on a conventional single harness loom rigged for 4-shaft twill. For this napkin, I'd probably need a gazillion shafts. You can see the problem if one starts to get ambitious with one's damask designs. The Drawloom solves this problem with its ingenious shedding mechanism, which allows the loom to serve as a rising shed loom and as a sinking shed loom at the same time. This feat is accomplished because of the loom's 2 independent harnesses, the ground shafts, which operate with a rising shed, and the pattern shafts, which operate with a sinking shed. First, let's remind ourselves how this thing is set up for 4-shaft twill. Here at the front of the loom are our 4 ground shafts threaded with a straight threading. We consider each group of 4 threads as a unit, which functions as a sort of block for design purposes. Each unit is threaded through a leash, a group of pattern heddles weighted independently of the rest. Oh, and there's Jensen's star of my design videos. Here we can see a leash with its 4 pattern heddles more closely. Every time I lift a pattern shaft, all the leashes or units on the shaft go up. If a draw loom is set up with single unit draw cords, each unit would be manipulated separately, but the principle is exactly the same. Let's proceed from the pattern shafts to the ground shafts. These are threaded with long eye heddles. At rest, all the warp threads lie at the bottom of the heddles, forming the floor of a rising shed. But if I raise a pattern heddle, the thread travels to the top of the long eye and becomes the ceiling of a sinking shed. Clear as mud? Let's see how it works in practice. First, we'll weave some of our weft emphasis ground cloth using the 4 ground shafts only. I'm not using the pattern shafts at all for this part. I'll do it the same way I would as on a conventional single harness loom. Let's look at the setup side on. I've strung a plumb line so you can clearly see that the ground cloth is being woven with a rising shed. Remember, at rest, all the warp threads are lying at the bottom of their long eye heddles. As I press each treadle, 1 warp thread in every 4 is raised. Since I'm using my countermarch, I need to tie up the long lambs appropriately. Remember, long lambs lift. The rising shed tie-up of the ground shafts is the same as the tie-up for our weft emphasis ground cloth. You can see that the white beads on the lambs are the same as the black boxes on the diagram we looked at earlier. Here's a section of the green weft emphasis ground cloth in progress. When I press a treadle, most of the warp threads, 3 out of 4, remain at the bottom of the shed. You can see the sparseness of warp threads above the card here. Only 1 in 4 warp threads has been carried to the top of the shed by a rising shaft. When I weave this cloth, treadling 1 to 4 repeatedly with no pattern shafts raised, I get my twill ground cloth with its green weft dominant side facing up. I can do this for as long as I want. The other side is its warp-dominant counterpart. Here I have another piece of cloth that I wove earlier for comparison's sake. Now let's weave some of that same ground cloth with the warp emphasis side facing up. Functionally, that means weaving the cloth upside down, with the yellow surface showing on top. To do this, I'll raise all my pattern shafts so that the warp threads are now at the top of their long eye heddles. See how they're now all above the plumb line? I have transformed my loom into a sinking shed setup. Instead of raising 3 out of every 4 threads as we would on a rising shed loom, I simply drop 1 thread out of every 4 instead. Fundamentally, it's the same thing. When I press a treadle, a ground shaft is now pulled down in accordance with the tie-up for the yellow cloth. On our original tie-up, white boxes indicated unraised shafts, so we will substitute our sinking shafts for those when we tie up the short lambs. Remember, short lambs sink. This is an ideal structure to weave with damask pulleys, in which case you would need these tie-ups only. The counteraction of the pulleys would take care of the rising shafts. So here I am at the front of the loom again, pulling all the handles on the shaft draw attachment to raise every one of the leashes. All the warp threads are now at the tops of their long eye heddles. When I press a treadle, 1 thread in every 4 is pulled to the bottom of the shed. You can see that most of the warp is above the card here, at the top of the shed. Now, when I cycle through my treadles 1 to 4 again, the reverse side of the broken twill cloth faces up. I have to take care with these picks. With so few threads on the shed floor, diving shuttles and skipped threads can be an issue for the unwary. Here's a close-up of the warp emphasis cloth I've just been weaving. So now let's see what happens when we put it all together and pull only some of the units for our row. I bet you can predict where this is going. For units that are not pulled, the long lambs will lift 1 thread in every 4. For units that are pulled, the short lambs will lower 1 thread in every 4. You can see the distinctive crossing of threads as the ceiling of one shed and the floor of the other intersect behind the ground shafts. It's cool. All this crisscrossing means is that in the same row, unraised units will be woven with a green weft emphasis face and raised units with a yellow warp emphasis face. The other side of the cloth, of course, shows the opposite. Because we are weaving 4-shaft twill, and each unit or design block has 4 threads, each pattern shaft is the equivalent of 4 shafts on a conventional loom with 1 set of shafts. The 10 pattern shafts in this setup give me 10 design blocks to play with, which would require 40 shafts on a single harness loom configured for 4-shaft twill. Now let's weave some damask. I raise the pull handles where I want to weave yellow warp emphasis blocks on the surface of the cloth that faces up. Above the card, you can see the areas of the cloth that will be woven in yellow. Down below are the units destined to be woven in green. Since this is a 4-shaft twill, each block or unit contains 4 warp threads. For each row of my pattern, I'll cycle through my 4 ground shafts, giving me a 4-thread by 4-thread yellow block wherever a leash has been raised. At the end of every 4-pick row, I stop weaving, reorganize my pulls, and repeat the process. Since this is only a 10-block pattern and the pulls are symmetrical and intuitive, the weaving goes pretty quickly. Look, my green leaves are already starting to appear. I should point out at this stage that this design is not original. It and other simple damask patterns can be found in Weaver's Delight, a compendium of popular projects, including several on the Drawloom, from Sweden's estimable Väv magazine. I highly recommend this book for your library. Now I'm almost finished with the bottom half of the pattern. I'll raise all my leashes and weave 1 more 4-pick row of yellow warp-based cloth before reversing my pattern and weaving out the other side. This is what the finished pattern looks like. And here's the other side that's been facing down this whole time. You can clearly see that it's the reverse of what's showing on top. Both sides look good to me, so I'll say this cloth has no right or wrong side. You have to imagine I'm making little air quotes when I say that. But this is not always the case. With some structures and designs, one side definitely can look more intentional than the other. We'll consider this issue in a future video when we examine tie-ups for other damask structures, including the use of two different structures on the same cloth. Please stay tuned.